Welcome to solverfy.
So the launch speed is 8.76 meters per second, or 8.76 kilometers per second, or 8,760 meters per second, which is less than the escape speed from the Earth. So, I'm going to use kinetic energy initial plus potential energy initial equals kinetic energy final plus potential energy final. Kinetic energy final is 0 because the rocket stops. Kinetic energy initial is 1/2 m v, which is v initial, okay, minus g, mass of the Earth, mass of the vehicle, over our Earth. And that's going to equal negative g mm over our Earth plus altitude. The m's cancel out, little m's. So I'm going to multiply by -1 on both sides. That's going to give me g m over re plus h equals g m over re minus 1/2 vi squared. Then I'm going to rearrange that so that it says re plus h equals gm over gm over re minus 1/2 vi squared. If I subtract re on both sides, then I have an equation for altitude. Here we need to know that m is the mass of the Earth, which is 5.97 times 10 to the 24th power kilograms. So let me put this into a calculator. GM, 6.67 times 10 to the -11th power times m, which is 5.97 times 10 to the 24th power, over GM again. So I'm just going to copy that. Over RE. I didn't write that down yet. Radius of the Earth is 6.37 times 10 to the 6th meters. Okay. 6.37 times 10 to the 6th power meters minus 1/2 v squared. V was 8,760 meters per second squared. that gives me about, I'm looking for my stylus so I can write this. I'm trying to. Okay, there we go. Okay, so that gives me H equals 16 times 10 to the 6th power meters. And I'll write 16.5 times 10 to the 6th power meters. I'm just going to make sure I didn't make any mistakes when I entered this into the calculator. GM. Oh, I did make mistakes. I didn't subtract off the radius of the Earth. Okay. RE was 6.37 times 10 to the 6th power. Okay, so now it is often good to check your work. That would be 10.1. Oops. We got 10.1 times 10 to the 6th power. All right. So let's look at part B. So it says that at a height of 2.51 times 10 to the 7th power meters, that it's at rest. So that means that the velocity, and we'll call that initial, is 0. So let's do this again. Kinetic energy plus potential energy equals kinetic energy plus potential energy. And we're concerned about striking the Earth. Well, the initial kinetic energy is 0. The initial potential energy is G M over R, but this is RE plus H. It's negative, by the way. Kinetic energy final is going to be 1/2 mv squared, where v is the speed of impact, minus gmm over r sub e. Okay, so just adding gmm over re to both sides, I get gmm. Oh, wait a minute. Let's cancel these m's out. Gm over re minus gm over re plus h equals 1/2 v squared. So we can factor out the g and the m. So it's going to multiply by 2 on both sides, and we get v is 2g m 1 over re minus 1 over re plus h, the square root of that whole thing. So let's go ahead and put that into a calculator. Square root of 2 times 6.67. Wait a minute, I've got GM already written down. Okay, so there's 2GM times 1 over radius of the Earth, 6.37 times 10 to the 6th power, minus 1 over radius of the Earth plus the altitude. Now, what was the altitude of this one? 2.51 times 10 to the 7th power. And that was given as an altitude, correct? Correct. Okay, and that gives me, I almost picked up the wrong pen. 9 point, well, if we round it to 3 digits, it would be 9,990 meters per second.